So let us get started, and today we'll talk about the monitoring with Percona Monitoring and Management. I guess you guys may have heard about that in some of the conferences. Some of you attend my tutorials. I show you some of the graphs for that. And what we'll do in this presentation is I'll talk a little bit about the PMM architecture, why we decided to do that. And then I'll also use an online demo to maybe show you some cool stuff about how it can be used. So the first one is the question, why did we really start working on this product, Percona Monitoring and Management? Well, this all goes back to really our vision at Percona. What we want to ensure is using both Percona branded software or what else exists in ecosystem, what to ensure there exists the completely free and open source products for vast majority of use cases. We do recognize that there are some very advanced stuff you want some proprietary software to use, but we want to make sure that's within edge cases rather than majority. Now, the monitoring management, I think, is a very critical component which is very much needed for the modern database infrastructure. And if you look at the typical monitoring solutions which exist as of right now, you'll find them either having a commercial license, right? MySQL Enterprise Monitor, Monyog, right, and many others. You'll have many of them which are cloud-based, right, and which require cloud deployment and which also essentially cost money, whether that's being Vivid Cortex or Select Star presented here, or a number of others like Datadog or New Relic, which is often used also to MySQL Monitor. And there are also a lot of ways that you can do it yourself, right? For example, get all those components together, right, like the guys we spoke about. You can build a monitoring solution on Prometheus or on a tick stack, or you can use Graphite, right, or Cacti. Lots and lots of tools exist out there, but they really require a lot of work to figure what you want to monitor, how to monitor, create a dashboard, and resolve a lot of other kind of complicated problems. So I believe it would be great to have some solution, right, which is exactly what we are speaking about here, which is 100% free and open source, which can be run in the cloud or on the premises, and which is easy to set up and use, right? Like you can really get up and running within the matter of minutes, not hours. What we also wanted to make sure is it is available for everybody on the team. Right? Why is that important? Well, because that is how you can really spot the problems essentially before they appear, like my T-shirt says, right? Then you can, if you can catch bad queries or bad indexes or whatever else bad in your test or QA environment by your developers, right, rather than by DBA in production, you would probably avoid downtime or poor performance impacting the users. Now, why this is connected to the free and open source? Well, because if you have a commercial software, then covering all your QA and development licenses, that may not be cost effective. We see a lot of stuff saying, hey, we can maybe buy this commercial thing for production, but not for development environment, right? Or at least not for staging environment, and of course not for developers who are just doing a lot of development right on their laptop those days, right? And we can't really buy the complete set of tools for everyone, right? Being free, open source, and easy to use allows to solve those problems. Okay, so let's talk about what PMM is. Now, what is our big picture philosophy here? Is we want to make sure we don't want really to reinvent the wheel. We are using as much of the best industry-leading components as possible, right? And really focus on how we can make an integration and customization easy. For some of that, we have to do it. Because if you look at some of those, many of those proprietary companies I mentioned about, there are tens, right, if not hundreds, engineers working on those products. right? And we can't really match them, right, to be frank. So the only choice for us to produce a great product with a relatively small engineering team is really not to try to do it own, but see how we can find out and integrate the solutions which exist out there. And that is what we have been doing. So if you look at PMM, we are using solutions like a Prometheus, right, for data capture, storage, and a time series database. We integrate that with Grafana, which is a very nice dashboarding system which makes many things beautiful. We also use MySQL orchestrator integrated, right, in PMM, right? All of those which are created, the open source project created, not by us. We just make them to work well together. Now, our current focus is want to make sure what we build it as a really best free and open source monitoring solution for MySQL and MongoDB. So we are very much focused on the monitoring right now. And the reason for that is we don't want to be kind of a peanut butter spread and trying to do kind of everything, right? We want to make sure we cover this area before we invest in much more broad functions of a management. So what currently works? Well, metrics for MySQL and MongoDB. We have a lot of data and a lot of very great insights. I think we have, I don't know, maybe 20 dashboards. I think now it's more than 100 different graphs covering operating system, database, and so on and so forth. And we are constantly working and refining them, well, not just to get the sheer number of those stuff, but we want to make sure each of them is useful, presenting the data in a helpful way, and really is providing some actionable insights, right? Because otherwise you can just throw the graph for everything in MySQL show status metric, right? For example, have many of them, but it may be not very helpful. We support Percona XDB cluster, Galera. We support Proxy SQL in addition to the core database engine. We make it possible also to monitor Amazon RDS as well. And what we also have a very powerful tool we have implemented in-house, which is a query analytics for MySQL, which allows you to go beyond kind of those global metrics, but really have deep insights about the queries, which queries need optimization, and so on and so forth. We also have an experimental integration with the orchestrator, as I mentioned. Now, in terms of alerting, we're not quite there yet. We integrate Grafana, which supports alerting, but due to various reasons, it's kind of has some of the rough corners right now, right? So we are kind of working with Grafana team how to figure out how to really do the alerting on the complicated infrastructure with all those complicated case. Our platform support. In terms of platform support, PMM comes in two components. Like one is your client-side component, right? Is essentially your agent which you install on the systems you want to monitor, and the server part which aggregates, analyzes, and provides graphical user interface for you. For server side, we are actually quite flexible. So we provide, you can run it as a Docker, you can use it as a virtual appliance with VirtualBox, VMware, you name it, as well as AMI if you just want to spin it up on Amazon Cloud, right? So it's pretty easy to get going on any platform. We have folks running it on, of course, Linux, on Mac, on Windows, it works. For client sides, for agent, right now we only support Linux, but that is where vast majority of MySQL deployments happens anyway, and that I think we'll look at doing more platforms if that's needed. The good thing though is as we built this in Go, then it makes it easy to support rather broad set of Linux distributions rather easily. So what do we have in works? What have we been working on? Well, support for longer retention periods, right? That is one of the things a lot of folks are asking about. We now support a very high-resolution data capture, but it will take, and you can really configure PMM to store data for as much time as you want. But if you configure retention period, for example, of 3 years, then it will take a lot of space and it will kind of be slow, right? Because aggregating 1 second data over years and maybe multiple instances is slow, right? So we will be looking for some solution for that. We're also looking for better support for cloud. We want really to make sure that it's something which is very easy to use, where you can actually add the cloud instances with no agent required and kind of make it more streamlined. We want that also to, in general, make that easy to use. That is a very big thing. Now, I would say even already now we have a lot of folks who would be getting with PMM up and running with PMM, and for a couple of instances in 15 minutes. So it's not that bad, but we really want that to be easier, especially for folks who are not very familiar with things as either Docker, right, or even command line, right? Because there are a lot of newer kind of generation developers which are not very familiar with all those, Linux packet management, right, and what's not. We are also working on query analysis for MongoDB. That is a big feature for us, and in generally improve the query analytics functionality and interface. So we want to make sure to make that much more powerful, especially dealing with large environments, right, where you're not looking at the servers one by one, but looking at servers as a group, right? For example, hey, I want to see what queries cause the most load on my MySQL replicas, right, and stuff like that. Right now, it's not quite handy. Yeah, and then also we are looking for alerting, right, to make that support much more powerful. Okay. Now, from one extent, you can be thinking about the PMM as something done by the expert, as Percona for the experts, meaning for really our internal teams at Percona, right? And we want to really make sure that the PMM is deep enough so it really assists our guys in support and consulting and managed services to resolve the most complicated problems, right? And we want to do that. We want to make sure there is enough depth out there. But at the same time, we want to make sure it becomes as easy enough for sort of non-expert use, right, for developers, and really providing folks some actionable advice, not information, right? So in the longer term, we want to build in some intelligence out there to tell you, hey, you know what, you should be adding this index right out there, or hey, you know what, we see you are not having the optimal size for your, I don't know, buffer pool, right? You should increase it, right? And we're also looking how we can integrate that with automation, with a fluid, dynamic structure, how we can use that information and intelligence to integrate with either havability, right, or automatic scaling and so on, right? A lot of that, of course, is kind of a longer-term focus of ours. Okay. Now, what do we do in terms of data capture? What data do we capture and how much of that? Well, our approach is this. For the most sensitive data, or for some of the data, we have 1 second resolution. And I think that is very important. Why is that important, right? Why is just having one data point, for example, per minute is not good enough? Well, because a lot of problems, before they become big problems which impact your customers, right, your users, they often originate as a small problems, right? So, for example, you may have certain, let's say, spike in the concurrency, right, on stalls on a disk I/O, which lasts for a couple of seconds, right? But if you ignore that, right, then they will become issues lasting for many seconds and finally minutes, right? And then that's where your user starts complaining. Having a monitoring system which has high resolution data allows you to spot and deal with those problems early on before they really impact your application in a significant way. Make sense? So we are doing that, and at the same time, we are capturing very large amount of data with a lot lower resolution, right? For example, information about the table statistics, right? How large are your tables and how they are growing. That is very helpful information to understand some trends, but you don't necessarily need it with 1 second resolution, right? I mean, which allows us to really perform a very deep analysis on what is going on. And what is great with Prometheus and Grafana combination is the amount of data you have in a system is kind of completely disconnected from a graph, right? And in many cases, you can have spot certain things in the graphs, right? And then you can go ahead and maybe use Prometheus interface on something to go deeper, right? And to find what the hell is going on. Now, if you look at the numbers, typically for every MySQL instance, right, or every host, we would have many thousands of different kind of time series, different metrics captured, right? Some of them with 1 second resolution, some with less than that. Really, it's very much instance dependent. So, for example, we do capture information about the tables, right? It's kind of could be one or like actually even several metrics per table. If you happen to have 10,000 tables, there would be a lot more data per instance than if you just have a 10 of them. Okay. So how is PMM really architectured, and what did we build that inside? So we have two components here on the server side and the client side. On the server side, we have an application for analysis queries as well as for our kind of metrics, which includes Prometheus for data store, Grafana for visualization, and then we really have a console inside which is used for discovery, but we don't really expose that to a lot of users, right? Unless you have some very a specific use case, you don't have to use that. And the idea here, by using the console, we are thinking about how we can then later integrate that with your environment, right? So for example, if you are using console for your general infrastructure kind of discovery, then PMM should be able to plug into your external consoles and really understand what kind of environment you have, right, without requiring you kind of to manage it automatically. And then for on our client side, we are using the standard Prometheus export over functionality to get the information from MySQL, MongoDB. We actually contributed a lot to those products, those projects to enhance the amount of data they provide. As well as we have our own kind of admin tool for simplified installations, and then also the agent which captures the queries for processing, right? It can capture queries from the log files or from Performance Schema, so it's quite flexible. Okay, so now let's take a look at the monitoring. I think how we can be thinking about that when you think about the database. Now, if you think about the database as a black box, right, without getting in all those kind of, buffer pool sizes and hit ratios, right, and latches and logs, right, what really it is from the application developer standpoint. And I think from application developer standpoint, that is something very simple. You, from application, send your queries to a database, right, your inserts, deletes, selects, right, and then your database, you want that to respond to requests, right? That's kind of very simple, right, in a nutshell. Now, as a developer, right, or as a database user, what do you want from those requests? Well, you, of course, want to get response. If you send and you send the request and it says, database is not available, I am down, that's bad, that's a problem, right? You also want to get quickly. That's what we always speak about performance, right? How quickly do we get the requests, right? And then finally, you want to get the right requests. You want responses to be correct, because it's very easy to get a very high performance in MySQL. Just alter all your tables into black hole engine. Right? Believe me, do that, and even your most complicated joins will return instantly, right? They will unfortunately not provide you the right results, right, in this case. So that would be useless. Right? And I think that is a very good thinking in this case, because what that means is if we are often looking at queries, well, if you're looking at those three metrics, we can really assess the health of a database pretty well. And especially, I think, their performance it happens to be most important here, because through performance, we can also kind of check availability, right? Because if database is not available, it's typically, well, you wouldn't be getting any queries to talk about performance-wise. And then in terms of correctness, that is often less of an issue. Well, I mean, it's of course a very important issue, right? But in the production applications, you often have performance problems happen with increased load, right, and so on and so forth. But that's not necessary problems with correctness, which are typically caught well by your QA in a small environment. Does that make sense? OK. So if you look at the problem space, now your problems, I think, can be really caused by three different areas, right? It's going to be application itself, MySQL, and some sort of hardware or environment of the operating system. Now, in terms of application, what problems could be? Well, it could be sending too many queries to the database server, right? Bad application design, or maybe we can say, hey, my memcache went down, so now I'm sending 20 times more queries than I has been. Well, that means application has to be fixed, right? So some other components external to MySQL. Bad queries, right? Developers like to write what kind of queries? Developers like to run bad queries, right? Write bad queries. So that is often causes problems, and again needs a solution on application level. And also, I would call it application level side, but it is kind of improper capacity planning. In a lot of cases, you think about I would say I see developers don't really think in a lot about the capacity planning. They think that database is something like this magic thing that you can throw any load at it, and with good DBAs can always make it work, right? Well, that doesn't work this way, right? In this case, database can do only what it can do, and you need to do proper capacity planning, right? It's like you cannot fit 100 people in your car, right? That doesn't make your car bad. That just makes you stupid if you try to do so, right? Well, the same idea applies here. Now, MySQL can be often guilty as well, right? So MySQL can be choosing bad execution plan, right? And how often that happens? That never happens? Yeah, that does happen sometimes, right? You know, we have some very smart developers like that gentleman on the back working to ensure it happens rarely, but it does happen sometimes. So we also can have contention issues. We can have some locking inside the database, which will be exposed in the query response time. And of course, a lot of stuff can happen on a Disco environment, right? You know, a CPU overload, slow disk or overloaded disk, not enough memory, slow network, especially I think in the cloud when there is like a lot of tenants sharing the same infrastructure, things can be quite messy and complicated. So what do we do in terms of PMM in our query analytic stuff, right? Well, first, we can really tell you what queries are causing the load on the system, right? So in this case, we are getting the top 10 queries and say, hey, which of them cause the load on the system? Now, what is also interesting next, we can take a look and see why are they causing the load. So in this case, we can see of a breakdown or of a different metric which corresponds to the query, which can be used to deduce why that query is performing poorly, right? So for example, for this query, I can say, hey, well, this query takes about a 10% waiting on a disk I/O. Well, that means if I even make my disk very fast, try to add a lot of memory, it's unlikely I will dramatically improve this query because it spends time in other areas, right? And also, we bring a lot of stuff on the same page, which can help you how to fix the query, right? So for example, we'll give you explain that query, which is a very powerful tool in MySQL to understand is the explain plan good or something you have to fix it. You can also take a look at the show create tables for tables involved and say, hey, you know, do it actually have a valid indexes? Is my explain bad because MySQL doesn't want to use the indexes for some point, or I just forget to create the indexes? As well as we can take a look at the show create table and really understand what is going on, out here, right? Is that large table or small table? Because in many cases that will drive what kind of queries, what kind of indexes are appropriate for workload. We also integrate that with a Percona toolkit, so you can take a look at and get the information about the system or about the MySQL instance, which can be quite handy, especially if you're working with a lot of servers. You may forget what kind of MySQL version it is running, how it's configured, you know, what kind of hardware is on this box, which is all can be often important to assess why you're getting performance or what you're getting. Okay. Now, graphs. That is, well, you can see this one looks like kind of a lot more nice and beautiful, and that comes from Grafana, right? That was, yeah. I think those guys are very good with making things pretty. So we have here information about what happens on operating system and hardware level, because I think for many MySQL problems, looking just at the MySQL level, you can't really troubleshoot it alone, right? You can say, hey, you know what? This query is slow, and it's now we're seeing it takes a lot of time even on a disk I/O, but what has been going with a disk, right? Is it overloaded because they're throwing too many I/O requests on that, or is there something wrong and it just started to serve them slowly? Looking at MySQL itself, it's very hard to get this kind of data. It's better to capture data from operating system as well. And as well as we provide information about the database level. Okay, so now I also mentioned we have the demo setup, and this is the demo we are going to look through. I'm going to show you some more interesting features when it's kind of internet permitting. I always prepare slides just in case internet doesn't work, because that does happen. But this PMM demo runs available for you. You guys can explore how it works with MySQL, with you know, with PXE as a cluster, with MariaDB, MongoDB. So we have a whole bunch of instances running different workloads, and that can be very interesting to play around and see what is out there. Okay, let's see now if we can make it work. Okay, so let's see some more. So oh, you're not seeing that, are you? You're just looking at my nice tiger. Yes, yeah. What the hell is that? It's low. Okay, nice. Now you see that, and I also can almost see it. Okay, so in this case, you can see our view of the queries, right, for some of the server. Now, one thing which is kind of handy here is you can click on the total thing, and it shows you kind of some summary over total query workload, right? You can take a look and see how many queries we're getting per second. You can see this kind of concept you see a lot, me using a lot, it's called kind of load. We kind of inherited that from load average, right? If you look about what load average is, that's pretty much how many there are, in average runnable process in the run queue blocked on the disk I/O, right? So in the end, we're also speaking about the same here, which pretty much tells how many queries are being processed at a period of time, right? So 7 is kind of medium, right? But if you have box which just two cores and one disk, and you see a load of 500, that means it's overloaded, right? It's processing much more queries. Now you can also see this nice spark chart, right? And you can see what the load wasn't uniform. So there was kind of a case when a server has load as high as 40, right? So that's some bad job run, which was nice. And then typically in normal case, it's kind of not that much, right? Now we can also take a look at a lot of the other things, like for example, how much of a query load here corresponds from a disk I/O, right? We can take a look, for example, another things like the query cache hit ratio overall, how many full table scans are happening, and so on and so forth. Oh, here is also interesting, right? In this case, what I like, you can see how many rows being examined per second, right? And in this case, it kind of tells us how many rows are being crunched through a second in average. And you can see in this case, it's 90K rows a second. That is not a big load. But if you have, many millions, it's like, wow, probably there are some badly optimized queries running. And I think what I like to look in this case is to look at the sort of the average query execution time, right? In this case, you can see it about 20 milliseconds, which is, well, depending on workload, maybe good or bad, but there is a high variance, right? We can see what there are some queries which are really fast, but there are some queries which have taken more than 200 seconds, right? So some of them pretty high. Okay, so now we can take a look at this at the queries and look at them, what exactly the queries are doing. And I will show this query as an example. So if you look at this query, you can see what this query is pretty rare, right? It just happens only periodically, but that is a pretty bad query, right? Where it takes more than 2 minutes, 2 minutes to run. Now, what is nice about this query, we can see is what majority of that query response time come from disk. So that is very disk-bound query. And if I'm concerned about speeding up this query, what should I do? Well, I should either add more memory or faster disk, right? That would be very natural if I don't want to deal with the query itself. Now let's look at the query example and understand what exactly that query does. Well, it's actually a pretty heavy query which does a pretty large range on a primary key. Well, again, that's a simulated workload, but you can see I can see all those things, all of the things right there, right? And I can see the size of a table. It's 20 gigabytes. We're scanning so many rows from it, and so on and so forth. Okay, so now let's do some Grafana thing, right? What is interesting? What is interesting here? You can see there is a lot of graphs. So let me show one thing. Start maybe from something that you have relatively unique here. So what this system shows us, right? And it's kind of gets a little bit crowded. But we can take a look at the, let's say, CPU busy currently versus 1 day ago versus 1 week ago. This is demo. It runs all the same workloads, so that is why you can see those graphs looks approximately the same, right? There is no difference. But for troubleshooting, that is a very valuable dashboard. Because one thing, if you have something broken, you want to understand, OK, what is today different from what it was before, right? And in this case, I can take a look and say, well, is my CPU today is different, right, than from the day before, right? And I can just select two of them if I like. Or maybe that was I/O activity, which is much higher, right, for some reason, or write activity. Or it can be I have a huge spike in MySQL queries, right? Those really often allows us to really point out our investigation by understanding from a high level what changed. Am I getting a sort of, let's say, more queries, or am I getting the same amount of queries or even maybe less queries, but I'm just handling them a lot less efficiently. OK, make sense? OK. So that is one dashboard which I like. I like a lot. So another thing is what we can take a look and see their system overview, which gives me a lot of high-level information: system uptime, amount of memory, how much memory available, distribution, how load average played, CPU, memory, right? You have some other systems like forks, processes, context switches, right? A lot of detailed system information which you can go and really on this dashboard, you pretty much get majority of the information which needs to understand is everything else going on operating system or something is unhealthy, right? For example, you may say, wow, there is a lot of swapping activity going on, right? And as you well know, swapping activity is not very healthy. Now, I can also go from there to MySQL overview, right? And here we provide you easy ways to transition, which kind of keep the same server selected here or same MySQL instance, which kind of looks very similar, but looks at MySQL. MySQL uptime, query, how large is the entity buffer pool, right? And frankly, we do recognize that majority of people run MySQL with InnoDB those days, right? So a lot of that is really InnoDB tailored. We can take a look at the active threads. Active threads, right? The threads running, that is a very common, a very good indication of how MySQL is kind of overloaded. If you have a lot of threads running, chances are something is not bad, is not good. Connections, also very healthy. We can be looking at the current connections, max used connections, and what is connection limit, right? If you're kind of pushing close to connection limit, then that is something you may want to be dealing with. And again, a lot of other information you can get here about the MySQL. Yes, absolutely. So it's just not on this dashboard. Now, what we also do in this case, and what we find helpful, is in many cases, look, I may have that like some of a spike, right? I can zoom into that, right, and maybe get into some more details. But now, often it becomes a question, OK, what do I may want to check the operating system for the same information, right? And one of the ways is, of course, to go ahead and jump to operating system, but we find that's often not very convenient, right? So what you can allow you is we also put the system graphs in the same dashboard, right? So you can actually look at what has been happening on the operating system level in the period what you are actually investigating, right? Often that can provide some very good insights. OK. So we have been talking about performance schema. We actually do capture a lot of performance schema data in this case, right? You can see information about file information, about about files in terms of bytes. Like you can see, for example, in this case, where in average, really the largest amount of writes come from energy double write, right? That's that is interesting. You can also look at the at the weights, right, where we get things are being weighted. And we often, in this case, you can see we try to look at those from two different standpoints. One is either looking at the amount of bytes or number of events. But typically what you're also looking is how much time did it take, right? Because if I say, oh, you know what, this event happens 10 million times, you'll say, well, tell me what, right? If that is very, very fast, then it may not be a big deal, right? And it's very hard for a developer to understand contextually which of events are what, right? And because of that, we are additionally to that, we're showing the load. And what load is, that is a concept again, number of events. As we discussed, right? That's a number of events which are kind of queued in a parallel. So high load for given event, that gives us more likely in a bottleneck. Now, in this case, you will find some of them have like a pretty weird high number, right? Like more than 1,000. Unfortunately, this is kind of performance schema artifacts, right? There are sometimes we're getting the data in performance schema which is slightly noisy, right? And there is very little thing we can do about that. Another, I think, which is very interesting data which you can get in performance schema is our index operations. So, for example, in this case, you guys have seen we have those expensive select queries which use primary key in SB test table. Well, you can just see it right here, right? You can see what, in terms of the operations, we have a lot, we have a pretty heavy load on that index, right? And that was kind of spiky. That probably what was the time when that select query was running. Does that make sense? Now, you also can look at the update and so on and so forth, and really to understand which of the tables and what kind of access paths are heavy, right? On a per index level, because that is a granularity what we can get with performance schema. We can also look at the same just on a table level. So if you can think about, hey, what are the tables which are getting a lot of heavy reads or writes, you can see it right here, right? We can see what in a DB table gets a lot of writes, and that is the largest part of a lot of reads. That's the largest part of a load. And then updates for InnoDB is the second part of a load, and then so on and so forth. Now, one thing, though, about the load, essentially, on this level, it looks like about kind of relatively high level. You would find what InnoDB spike and update spike, right, sort of comes at the same time, right? While if I know a workload and I can tell you number of updates wasn't changed in this case. So why is there a correlation? Well, because that's how systems tend to work, right? If you put some very heavy workload on the system, then everything else tend to become much more expensive as well, right? So if I overload my system with reads, then a lot of pretty simple other reads or writes, right, they also become slower. And that is why it's very helpful to look at the query level we just see, because I can see, wow, at this time I have that nasty query being run, right? And that is why it's happening. Okay, performance schema. Now, in a DB, there are a lot of nice InnoDB metrics we have here as well. One thing I mentioned yesterday in my tutorial is InnoDB checkpoint age. Very nice way to check if your InnoDB log file size is adequate. And you can see in this case it's kind of going back and forth. But for this workload, I don't need very large, much larger log files. If I would, then I would see my max checkpoint age kind of getting closer, much more close to checkpoint, to energy checkpoint age. We can look about the history length, right? Again, so if somebody was at my tutorial yesterday, I spoke at length what long history length can be very bad for performance, especially if it's sustained over a long time. In this case, I think it's kind of not a big deal, right? It goes to 1,000 like for like a minute maybe, and then it goes back, so everything is working normally. We can look number of row operations. We can look at row logs, right? And this is also very interesting, where you can look at different measures out there. The average log time, that's one helpful measure. We can look at how many row log waits are happening, right? And you can see in this workload, I almost have no row log waits, right? That doesn't mean my workload didn't work any row, but that just means there was no conflict. Row log wait and then means that two more transactions try to access the same row, and that happened. You can see it happening here. And what is also very nice here is you can see what I call row log wait load. That is essentially how much weight was associated with that. So you can see when this kind of workload happened, up to 20 transactions at the same time were blocked waiting on row logs. Like, that is a lot, right? And I think that is something you can really understand. What does that mean for your application? Much better than number of row log waits, right, or average log time. Because if you have a lot of row log waits, but they're very short, right, that may not have a significant impact for your workload. OK. So what else should I show you? Oh. I also have this very nice initiative. It's probably merged into this dashboard, but it's called, where is that? Advanced energy metrics, right? That allows us to get a lot of insights into advanced energy functions, right? For example, change buffer performance, right? So in this case, I can understand how many inserts, how many merges are going into my change buffer. I can also understand, let's say, insert buffer merge ratio, right, to understand if my insert buffer is actually helping me well, or maybe I should disable that because I just waste time. I can understand my log buffer. That is also quite handy. So in this case, you can see my log buffer is just 32 megs, right? Not a lot, right? But I can see really, if I look at amount, how much is used, it only goes up to 2 megabyte tops, right? So even though I essentially have a very small log file for this workload, that's more than enough. And I think that is very hard for many folks to understand. How much space do I really use in my InnoDB log buffer? Well, not really. You can look at that. We can take a look at how InnoDB purge working, what exactly our InnoDB main thread is doing. And in this case, we are, because InnoDB has a single main thread, you can think about that as to what extent that is busy. And you can see what my main thread is busy up to 15% of the time, right? Now, what you don't want to happen here is your InnoDB main thread getting into 80, 90% busy, because if it becomes too busy, then it may not be able to do everything it has to do, schedule various kind of stuff and whatever, right? And then you may have some nasty things going on. Okay. Well, so at this point, I am having that nice lady on the back out here sending me strong shut up signals. So I can end and take a couple of questions if you have any. Yes?
You mentioned not just providing permission, but also advice.
Yeah.
Do you have any advisor?
Yeah. So what will be going on in the later part, I think that's not deployed here, but we are getting for all of those graphs, there are Grafana allows you to put some advice. What that means, what should you expect there, and that is one thing what we want to do. The other thing will be also integrate that with alerting in a way we can say, hey, we see those 5 things which are kind of wrong for a system. That's something you want to check out, right? Yeah. So That's in the plan, right? Lot of works remains. It's just version 1. The GA is less than 1 year old, so please be kind. Try it out. Give us a lot of feedback, and also, you can actually write code. That's an open source project, and we have already a number of good contributions out there. Okay. Yes. What's that? For Mongo? Yes, we are working on that. That should be done in the next few months. Yes, we are working on that. That's right. Yes. That is very interesting, right? So, if you have a query which is you have a row log format, which is a statement, right? And log slave updates, you will see slave updates here, right? If you have a row log format, then you would not see that. But you will see that workload, for example, in what kind of tables are contributing the most load, and so on and so forth, right? Okay. Well, let's be respectful to whoever will come and speak after me. And if you have any questions, I'm not going anywhere. I will be on the conference until the last day, so feel free to ask more questions. Thank you.